And now the big question we're going to answer is, are vector bundles really a stack? And I guess I've already spoiled it, but let's get into it. Is Vect a stack? And for that we should revisit the definition of a vector bundle, because there are two approaches to vector bundles. On one hand, we can give a vector bundle as like this manifold together with the projection map, but we can also sort of do the bottom-up approach. So we can define a vector bundle using local data, namely by providing a cover UI of I, so in our notation we call that this, and giving smooth maps phi ij from uij to gl and R, where n is supposed to be the rank of the vector bundle, such that, and now we again have our famous cocycle condition, we have gij of p times gjk of p times gki of p is the identity matrix for all p in uijk, and we have gij of p, gji of p being the identity matrix for all p in uij. If we are giving this, then we can define, or this gives a smooth vector bundle of rank n by just defining our bundle to be E is the disjoint union over all I and I of ui times r to the n modulo some equivalence relation, where for some index I, point p, and a vector v, that one is equivalent to another index j, the same point p, and then we have gji at the point p applied to v, and this just means that v is supposed to be some vector over ui, and then we use gji to map it to uj, and I guess p is in uij and v is in rn. And our bundle projection map pi from e to m is just given by any I pv maps to p. And because in this equivalence relation we didn't mess with the point p, that is well defined, and well, you can check that it's smooth. Now this implies that we can really glue any kinds of vector bundle. How so? If we're given vector bundles on some cover ui, then we can just find a trivializing cover for that, because if we go to a small enough cover, every vector bundle looks like trivial vector bundle, and we can do that for every ui. So then we find a very small cover of u that consists of trivial vector bundles, and then we can invoke our construction from above. Similarly, and I didn't really spell that out, but vector bundles are also sheaves, so we can glue sections of vector bundles. So in particular, we can glue sections of Hom bundles, which means that we can glue morphisms of vector bundles. And as I pointed out in my video on descent data, this means that the descent data functor is essentially surjective for every cover, and this means that it's fully faithful for every cover, meaning that all in all, it is an equivalence of categories for every cover UIU. The descent data functor is an equivalence of categories, implying that Vect is a stack.